All right. Yes, I'm recording. Okay. We had a certain form yesterday that we got to use the parent graph for. That was if it was some constant on the top and then just x plus or minus something on the bottom. And you noticed on the homework if it was x squared, that did change the parent graph a little bit. But then you can always base it off the parent graph. But now we're going to start doing what if there's more variables in the numerator and it doesn't work out quite as easy. What I'm going to show you here are kind of some of the shortcuts that I like to use, and I'll also kind of explain what the book actually wants you to do in case you want to go that route. But we noticed yesterday that some of the graphs, especially 1 over x, so if this is our kind of original right there, 1 over x had a vertical asymptote right there and a horizontal one right there, correct? It had 2 of them, and it just kind of did something like that for 1 over x, correct? And so we're going to try and find out, the functions are going to get a little bit more complicated, and we're still going to try and find out where are those asymptotes. Okay? And we're going to try and go about it in the quickest way possible. So one of the steps that I like to do, and one thing you should probably write somewhere on your notes, is to always look for holes first. Always, no matter what. And holes was from yesterday. If you have factors that cross off, please always look for them first and get rid of them, and then do the rest. But otherwise, if I want to find out vertical asymptotes, so in other words, this one here that was at x equals 0, right? What I have to find out is which x values am I not allowed to put in. And the x values I'm not allowed to put in are the ones that make me divide by 0, right? And so that's why, to do that, all we have to do is set the denominator equal to 0 and figure out what x value actually makes it say 0. Because then that's bad, because that's dividing by 0. Okay? So why don't we go and do that for this one right here? So this one right here, do you believe that that x and that x cancel? Is this like before? Is that going to be a hole? Do those two x's cancel with where they're at? Okay. Now let's say you were confused about that. The rule I gave you yesterday or the other day was just put a number in there. So it'd be 6 over 6 minus 1. Can you do that? No. So if you can't do it with a number in there, should you do it with a variable in there? No, because a variable is just representing a number, right? So don't cancel those off, please. Okay. So there is no hole. So we looked. We didn't find it. So now step 1 says, let's set the denominator equal to 0. So in other words, x minus 1, because that's the denominator, right? Let's set it equal to 0. And if we solve that, we would add 1, right? So we find out that x equaling 1 is good or bad? Actually bad, right? Actually, x equaling 1 isn't a hole. X equaling 1 does what to the denominator? Makes it 0. And dividing by 0, the one thing not defined in mathematics. So if I put 1 in, let's say I was sitting here at an XY table, and I was going through all the points, and I tried this one, am I going to get a Y response for this graph? Ever? No, I'm never going to be able to get one. And so what happens there is that is your vertical asymptote, because do you agree that, I hope you agree, that x equaling 1 is a vertical line? If you just had to graph that line, you would graph x equals 1. But when we do that, we're going to graph, whoops, well, I gave away that. All right, so there's x equals 1. It's actually that one right there. That one. Okay. Now that one, that's a really good shortcut, and that's actually just how the book wants you to do it, is find out what makes me divide by 0. So that's really not that bad. It's the horizontal ones that the shortcut's a little bit more complicated, but it's way easier than doing what the book wants you to do. Okay? Okay? So for horizontal, here are my shortcuts. There's one of 2 options. Option A, the numerator and denominator have the same degree. Remember on that worksheet from a couple days ago, degree means the highest exponent, right? So if they're the same, all you have to do is kind of look at the fraction, and let me explain that. Let's say I had x squared, well, that's 2x squared plus 7 over 3x squared minus 3. Do you agree this fits into the category of them having the same degree? So what's the degree of my numerator is? 2. The degree down here is 2. So they have the same degree. So what we would do is, really that doesn't matter and that doesn't matter. We're going to look at where the variable is. Okay? And look at this fraction right here. Okay? 2/3, agreed? So in this case, it would be y equals 2/3 is going to be your horizontal. Okay, and once we do this next one, and I'll show you on here, and I'll explain why that works. Okay, now that's if the powers are the same. Okay, that's what you will do. Okay, that's option A. Option B is if the denominator has a higher degree, then the horizontal asymptote is automatically y equals 0. There is no more work to do. So an example of that would be, let's just start with the same thing, 2x squared plus 7, plus 7 over 3x to the third minus 3. Degree very closely related to the last one, correct? But the degree now down here is 3, the degree there is 2, so the bottom is bigger. Okay, so my automatic answer is y equals 0. Now I could understand why these shortcuts could be hard to understand. Okay? But what the book wants you to do is find the inverse of the function and then set that denominator equal to 0. Way more work. Because I don't know how many of you are going to be able to find the inverse of that function. X over x minus 1, that's kind of complicated. I could do it for you, but it's going to take a minute or so. Yes, we have a question. Great question. I don't think anybody's ever asked that at this point before. The question was, what if the top is bigger? And that's such a great question that we save it for another day. Okay? If the top is bigger, though, I will give you a hint into the future. If the top is bigger, there is no horizontal asymptote. Okay? If the top's bigger, there isn't one. Okay. So here we go. X equals 1. Now, which shortcut should we use on this one for the horizontal? The first one or the second one? Is the degree the same, or is the bottom bigger? The degree is the same. Well, wait a minute. There's no degree on this thing. What is the degree of the numerator? Yeah, understood 1. Very good. And then down here, and understood 1. So what are we supposed to do? What does that shortcut tell us to do? To look at this fraction out here. So it's a 1 understood over a understood 1. So 1 over 1 is 1. So it's y equals 1. And now I'm going to try. Unfortunately, you already saw it, right? Because I hit the wrong spot. Or maybe it won't work now. There we go. There are your asymptotes. The reason we couldn't use the transformations from before is there's a variable in the numerator. Okay, so we couldn't do that. I'm hoping you can see why the vertical asymptote is where it is, because x equaling 1 is never going to give me a response for the y value. Never going to work. But here's how I look at it. For horizontal asymptotes, let's pretend that for x, we're sitting at this xy table, but I decided I was going to do a weird one. Like x being 1,000. It's kind of a big one, right? If I put that in, I'm just doing a big one, you'll see why. If I put 1,000 in, what happened? It's 1,000 over 999. What if I was really being weird? And I said, oh, let's do that, 10,000. Then it turned into 10,000 over, right? So as I keep going further and further out, what number is it going to keep getting closer and closer to? Do you agree that this number here is really, really close to 1? Is it ever going to get there, though? No. Isn't that what asymptotes do? Keeps getting closer and closer to it, but it never really gets there. So as I go further and further out, it's going to keep getting closer to 1 and closer to 1 and closer to 1, but never really get there. Okay? So can you see that basically it's just going to do that right there? Okay. What if I throw a negative in, though? Being weird again. Let's throw a negative 1,000. Negative 1,000. So it's a negative 1,000 over negative 1,001. Do you agree? Wait. Is that right?
Yeah.
Yeah, okay. I was worried about that for a second. So it goes to really, really close to 1. What if I went further out? It would be even closer to 1. So you see, as x gets big, is that really all that important as x gets really big, positive or negative? Does that minus 1 really affect things all that much? So aren't I really putting the same number over itself for the most part in general? Isn't that what we're really doing? And so that's why you can just look at that fraction, because it's just going to tell you where it's going. Okay? And so this one's getting closer and closer to positive 1, and we could test this out, but it's actually going to do this. Okay. No, that was just, the question is the second one way closer? No, that was just me just throwing a sketch in there. Yep. And if we really wanted to find out where those were, we could obviously get some x or y values on that. All right. Any questions so far? I know this is weird. You're going to have to hang with me. Are we good? Did that explanation at least somewhat make sense? As x gets really, really big, look what happens. Where does it go? That's what you need to find out. Okay? As x gets big, way out there. Well, let's try another one then. What are we supposed to do first again? Look for holes. Well, the numerator doesn't factor. Does the denominator factor? Nope. So any holes? Nope. This one's good. So look for numbers that would make the denominator 0. So in other words, what x values am I not allowed to put in? So let's set this equal to, let's find out what's going to make that be 0. Algebraically, what would we probably do? Subtract 2, right? So x squared all of a sudden equals -2. And we would square root, falsify, so x equals positive and negative square root of -2. What is the square root of -2? No, that would be +2. Yeah, this is imaginary, isn't it? This is an xy axis, agreed? Is there any imaginary component of the graph we're looking at right now? No. So does this one actually have a vertical asymptote? It does not. It doesn't even have one. Not applicable. Or empty set. Doesn't have one. Okay, or none. Yep. So of our shortcuts for horizontal, so it can still have a horizontal. Which shortcut should we use? First one or the second one? Okay, and the second one says if the bottom is bigger, which is what we have, the automatic answer, no work involved, is y equals 0. Ooh, that's pretty good. All right, so y equals 0. Let's see if I can get this to work. There we go. Now, vertical asymptotes, when you have them, have to follow the rules. I mean, there is no crossing a vertical asymptote. You cannot cross it ever. Okay? Horizontals sometimes misbehave. Okay? Some of us in here might know about that. Okay? But we're looking at as x gets big. So as x gets big, let's see if we can figure out why that's the horizontal. So as x gets big, again, if we're making an xy table, let's just get silly again. 1,000, right? So it'd be 1,001 over 1,000 squared. So 1,000 squared is really, right? And the further I get out, do you agree that the denominator is going to get way bigger than the numerator in a hurry? So you got kind of a big number over a huge number. So once again, do these really affect all that much as x gets big? Do they really affect the process all that much? Not really. But x over x squared, so you agree that the denominator is going to get huge really fast. So some number over something really big really is going to what number? 0. Okay? So like 1 over a million, that's pretty close to 0. 1 over a billion, pretty close to 0. And that's why it's y equals 0 is where it's going. Okay? But this is a very strange graph, and I'm not going to give you very many of these, at least not necessarily on purpose. But let's see what happens on this one. This one actually misbehaves. Watch what happens. It actually crosses right there. But it comes up, and all of a sudden the asymptote pulls it back in. And this one crosses, and the asymptote pulls it back in. Okay, great question. How would we know if that's going to happen? And I can't give you a steadfast answer on that. Okay, but we are going to be using technology to help us out with those. We're going to see if they cross. Okay, right now my goal is can you find the vertical and can you find the horizontal? That's my goal right now. Because I'll be honest, even doing it the way the book wants you to do it with the inverse, again, try and imagine finding the inverse of that thing. Okay, I would need to teach you new strategies to find the inverse of that function. Okay, and so we're doing it with the shortcuts. Okay, it could be done, but it's just way too long. Not even doing it that way will point out when it's going to misbehave. Okay, so it's really hard to tell. Okay, and sometimes even when they look like this, it may misbehave, even when they look like that. Okay. Questions so far? I'm throwing a lot at you here. Whoa. Ooh, somebody yelled out, factor it. No, we're not going to skip this one. All right. So the numerator is 3x to the third plus 2x squared plus 7. I don't know about you, but I'm not too sure how to factor that. Okay. The bottom we could factor an x out of if you wanted to. Okay. But if we factor an x out, what do we got left here? X squared minus 2x minus 3. Does that match anything in the top, though? No, and then we could try factoring that next piece. Does that factor? I think it does. So let's just try and factor this piece. So it has to multiply to be -3 and add to be -2. So now you're probably starting to see why some of those worksheets we had before this chapter started, why we did some of those. So we've got this x still hanging out here, right? So do those numbers, -3 and 1? Let's see, does that work? -3 and 1. So now there is a 1 out front, so the shortcut is, if you want the factors, just to do that and write them down, right? Only when there's a 1 out front. Because we can see that if I FOIL this out, it is x squared minus 3x plus 1x minus 3. So we actually do get the same thing. Does any of that cancel with the numerator? No. Why do we just waste our time doing that? Who said to factor this stuff out? Okay. Well, luckily, that person is actually still pretty accurate. It does not cancel with the numerator. I agree, which means there's no hole. But what's step 1 anyways? To find vertical asymptotes, we set the denominator equal to 0. Well, here's our denominator right here in really nice factored form. So here's step 1. Let's find those verticals. Let's set this equal to 0. So in other words, for this to equal 0, this is all multiplication, correct? So for this to equal to 0, either that one has to equal 0, or this factor has to equal 0, or that factor has to equal 0, right? Because 0 times anything is 0. So let's set this one equal to 0. Ooh, that was tough. Now, notice that if I put 0 in for this one, I do get 0. If I put 0 there, I know I get -3. I understand that. And if I put 0 in there, I know I get +1. But it's 0 times -3 times +1, so the end result is 0. So that's why this little maneuver that we're trying here only works if you're trying to set it equal to 0. So x minus 3, well, what's going to make that one say 0? That's if x were to equal 3, right? Again, it makes this middle one equal 0. And all I need is to have one of them equal 0 for this to come out to be 0. And then the other one is x would equal -1. So wait a minute, whoa. We just went from example 2 that had no vertical asymptotes to example 3 that has 3. Whoa. Okay. So here we go, x equals -1. I hope they're in there. Maybe not. There it is. X equals 0. Rapid tapping's not working. Well, let's try 3. Well, that one's in there. Well, I give up. That's a lot of verticals. Oh, hey, this one didn't even ask me to graph it. What am I graphing it for? It says determine the asymptotes. Awesome. All right, well, let's do step 2 then. Step 2, find. So this is vertical asymptotes up here. So this one will be horizontal asymptotes up here, down here. What do we do for that again? I don't think guess and check is going to work. How do we find it? There's 2 shortcuts for that. And I've been told to use the first one. What's the first one say? If the top and bottom have the same degree, correct? Okay. So they have the same degree, so let's get rid of that. So remember, this is supposed to be as x gets really big, correct? So as x gets really big, like 10,000. If I put 10,000 in here and I cube it, do you agree that gets really, really large? So in the end, is that +7 really going to do much for me here? No. Even if I put 10,000 in there and square it, does that even compare to the 10,000 cubed? Not even. It's so small, it doesn't even compare to that. So we don't really care about those. How about down here? Put 10,000 in there. That's not all. That's not big. That's not it. Okay, so we just look at this fraction. So it's 3 times 10,000 cubed over 10,000 cubed. Again, I'm just picking a large number. So 3 times 10,000 cubed over 10,000 cubed really just comes to what number? It gets really, really close to 3, right? So you see what I mean by just look at that fraction, it's 3 over 1, and I'm looking at the coefficients. So it's y equals 3. There, rapid tapping worked that time. Well, there's your asymptotes. And this is definitely one of those cases where we would go get the graphing calculator and find out where all that stuff was. Okay. Yeah, the graphing calculators do not deal very well with these, especially the 83s. Okay. They just connect points. So sometimes if you have, like, let's say the graph is supposed to be like this. Sometimes here's what the TI-83 does. Oh, I'm finding points. Where's the next point? Oh, it's up there. And it just connects them like that because it doesn't know what to do. Because it knows one of the points is here and it knows the next point's over there, and it just connects them. Now on the 84, they fixed that problem. I think they just don't show anything. Okay, but it would be really nice if somehow we could have the graphing calculators actually show the asymptotes somehow. I think it would be very helpful. Okay. So that one we would use as the calculator to find out where this stuff goes. I could probably invent it, yeah. All right, let's try one more before I set you off on your own. Any ideas? Factor, yes, because what are we looking for again? A whole. All right, well, let's figure this out. Does this even factor? Have to multiply, be careful, to be what? -6 and add to be -1. Are those rational numbers? -3 and 2, I've been told. Does that work? -3 and, yep, okay. Now, can I use that shortcut we used in the last one? Unfortunately, now there's that 2. All right. So let's go over here and use up some space. So it's 2x squared. What happens to -1x? So it becomes those two numbers, -3x plus 2x. And everybody's favorite is squiggle. Now, what do these two things on the left have in common over here? X, anything else? Oh, that kind of stinks. All right, so it's 2x minus 3. So we need a 2x minus 3 over here. And you have to take out a positive 1. You have to take out something. Okay, so our factors are x plus 1 and 2x minus 3. So that's what my numerator is going to become. So there's my numerator. How about my denominator? It factors. Let me see how. Yes. Not quite. Somebody said difference cubes. Not quite, because it's really hard to cube to get x. The cube root of x would be tough. Yeah, there's a 3x in common, though, right? If I take that out, I get x squared minus 1. And x squared minus 1 is difference of two squares, correct? Okay. Look at all this algebra coming back. It's awesome. So if it's x squared minus 1, it becomes x minus 1 and x plus 1. Whew. Boy, that'd be a pain if we did all that factoring and nothing happened, like the last problem. Oh, wait, something did happen this time. What happened? This one has a hole. Can I erase this factoring? Has everybody written that down that wants to write it down? So now we know there is a hole at x equals what? Well, you got to take whatever you just crossed off, and what makes that 0? -1. Because again, I could set -1 in here, and it's going to make the bottom 0. I guarantee it, which is bad. Right? But we took it out. It's gone. Well, now what do we got left? We've got 2x minus 3 right here over 3x times x minus 1. So now go with what's left, and let's find vertical asymptote, otherwise known as step 1. So for vertical, what do we do again for vertical? It's the x's that I can't put in, right? So set the denominator equal to 0. I already know that -1 is going to make it be 0, but I know -1's a whole, right? So don't look for it as an asymptote. So again, if I'm going to set this equal to 0, I can set each piece equal to 0. Well, that's supposed to be an equal sign, sorry. So how about on this one on the left? 3x equals 0, so divide by 3, so x equals 0. And how about this other one, x minus 1? Add the 1, right? So x equals 1. So there's your vertical asymptotes. Interesting to see what people do with this one. For horizontal asymptotes. You can do it at the original, or you can do it on the factored version. But please realize that this is 2x and then this is 3x squared, right? If I multiplied it back out. So to agree that no matter if I look at the original or the factored form, the bottom's still bigger. Everybody see that? Some people look at the factored formula and they're like, oh, it's 2/3. Because they fail to realize that it would actually be x squared when multiplied out, right? So, or a lot of people just look back here. So the bottom is bigger, correct? What's the automatic answer if the bottom's bigger? Y equals 0. Because again, as x gets bigger, that denominator is going to just get ridiculously large, and it's not going to work out. And all I said was find the asymptotes, so we don't have to look at that graph if you don't want to. In fact, I'm not sure I have that one. Oh, I do. All right, I'll show you what it looks like. If it'll work. Hey, they both came out at the same time. That was pretty cool. Did that happen last time too and I didn't notice? No? Okay. Okay. So I'll show you what it looks like. Over here, we basically have this going on. And you would just put x values in and see what was happening. So it looks something like this. And in here, I'll tell you what, between vertical asymptotes, pretty much it's kind of like that last day of homecoming, anything goes. Right? You can do anything in there. It turns into an actual really skinny parabola. And then over here, we got that one. But that graph is not quite correct for some reason. Why is that not right? Yeah, I got to put the hole in. So the easiest thing to do is just go, where's the hole supposed to be? At an x value of -1. So you go over here to -1, and you go on down, and you say, yep, there's a hole right there. Especially if they're sketches. Here, we'll slide this over a little bit more, and there you go. Of course, I got to figure out exactly where that was by substituting it in, but. Questions?